So dehydration means removal of water. Removal of water and dehydration of alcohols takes place at a specific temperature. Temperature is 440 Kelvin and in presence of concentrated sulfuric acid. Concentrated sulfuric acid. This is the condition. Conditions have to be written. If no condition, then half marks is cut down. Conversion can 3 marks. So if you take ethanol, so in this condition it forms the this is dehydration. But its mechanism is very important. Mechanism is important. So mechanism is divided in 3 steps. First is protonation of ethanol. Protonation of ethanol molecule. Ethanol is protonated. Protonation, addition of proton. So C2H5OH plus proton. This proton is from sulfuric acid, and as a result, there is formation of C2H5OH. So this carries the oxygen carries the positive charge. So what is it? S2. What is this? The name of this compound. Name of this compound. Okay? No idea? When oxygen carries positive charge, it is called as what? Oxonium. Oxonium. So it is ethyl. It is ethyl oxonium ion. It's very simple figure. When oxygen carries positive charge, it is called as oxonium ion. Carbon carries positive charge, it is called as carbonium ion or carbonium. So this is the first protonation of alcohol molecule. So temperature is specific 443 Kelvin. Concentrate sulfuric acid. This is the only condition. Now we ask that, sir, we cannot use hydrochloric acid or sulfuric because hydrochloric acid is very weak. Hydrochloric acid is very weak and it cannot remove the moisture. It cannot take out the water from the molecule of alcohol. 1 point. Why cannot use the nitric acid? Because nitric acid is very strong oxidizing agent. Are you getting a point? Nitric acid will cause destruction. It will oxidize the alcohol completely and will be total waste. So we cannot use hydrochloric acid or sulfuric acid. Just I am asking and explaining for your examination keep in view. See, teaching is not important. Point is that what you give, what you learn, what you assimilate. This is the first point. Now, as you know, oxygen carries positive charge, so this oxonium ion and carbonium ion, they are highly unstable. They are very reactive. So this oxonium ion will undergo dehydration. So second step will be dehydration. Dehydration of oxonium ion. Dehydration of oxonium ion. As it is highly unstable, so it will undergo dehydration. It will lose water molecule. So C2H5OH, it is very reactive, very unstable. So it will undergo dehydration and there is formation of C3H2 plus, or you may say CH3H2, or you may write like this. Both are correct. So this is what? What is it? Carbocation. Ethyl carbocation. Ethyl carbonium ion. Ethyl carbonium ion or ethyl carbocation. So this is the second point. Second step. And all the 3 steps they carry around 1 mark. If it is correct, they will get 3 marks. If you are not correct, you have written some wrong, so 1 mark minimum will be written. Now, so this is highly unstable. Oxygen is highly unstable, it is also unstable. So it will undergo deprotonation. So there will be deprotonation of carbonium ion. Deprotonation of carbonium ion. Deprotonation means loss of carbonium, loss of proton, loss of hydrogen ion. So this CH3, CH2. So very quickly it loses H plus ion, and there is formation of C2H4. So this is ethene. So this is very important part to explain the mechanism of dehydration of alcohol to form the alkene. Now I am going to explain about the very important part, acidic nature of phenol. Why phenol is acidic in nature? So acidic nature of phenol. Now phenol, this C6H5OH. This children OH is there in phenol. Similarly, NaOH, it is a strong base, but it is acidic. It is distinctly acidic in nature. Not very strong acid, but it is distinctly acidic in nature. Means it responds litmus test, that it turns blue litmus red. It reacts slowly with the sodium bicarbonate solution, reacts with sodium carbonate solution very slowly. But NaOH, it has OH, it has this. Now making it slightly difficult, more difficult. I am comparing with C2H5 OH also. Alcohols, alcohol, they have also OH. So all the alcohols are what? They are neutral. So this is very important part. OH is present in this and this. In spite of this, phenol is acidic, NaOH or all the bases are basic, and this alcohol is neutral. Why there is such variation? So answer very simple. First, NaOH, it is strong electrolyte. NaOH undergoes dissociation to form the sodium ion and the OH ion, because the size of this sodium ion is very large. It is in the S block. As a result, the bond between the sodium and OH is very weak, and that's why it is very quickly able to provide OH ion, and it is basic in nature. Now coming to alcohol. So in class 11 we have read about the alkyl groups. Alkyl groups, this are alkyl groups are they are electron donating in nature. Electron donating or electron releasing. So it releases the electron. So what happens? The bond between this C5 and OH, it is strong. It is strong, and as a result, it is unable to be polarized. It is unable to be able to lose the OH as such under normal condition. I am referring to this under normal condition. That's why alcohol is neutral in nature, because of its nature. Now coming to our main point, that is the acidic nature of phenol. Why phenol is acidic in nature? So it can be explained by the resonance stabilization of phenoxide ion. Now this phenol, it is stabilized by resonance, and there is the formation of phenoxide ion plus S3. This is phenolcyde ion. How it is stabilized? It is stabilized. I am drawing this, and it is stabilized by this. And the result of this peroxide ion is able to react with the water, and hence there is the resonance stabilization. Resonance stabilization. It is stabilized by resonance. Is that clear? There is resonance stabilization. Now I am going to explain about the very important part, stereoisomerism. Stereoisomerism. So in stereoisomerism, there is the formation of isomers. Now in stereoisomerism we call enantiomers. Stereoisomers are called as enantiomers. So isomers now are called as enantiomers, or simply the stereoisomers are called as enantiomers. Meaning of stereoisomerism means the three-dimensional geometry. Three-dimensional geometry of the isomers. So it is defined as the process or ability of isomers to form various molecules which differ from each other in terms of orientation. Means 3D geometry. They have to be taken into three-dimensional. Now, enantiomers, they are of two types: dextrorotatory and levorotatory. Dextrorotatory and levorotatory. So in stereoisomerism, we take some basic points. How the isomers, how enantiomers are obtained. So enantiomers are obtained by some specific conditions. Conditions have to be fulfilled. But before this, first see some of the basic concepts, how we are able to get the required condition. So here there is a ordinary light. This is ordinary light. In ordinary light or plain light, simple light, the photons or quanta, they vibrate on 360 in all the directions. But when we pass this ordinary light through Nicol prism, this is Nicol prism. Nicol prism, it is special type of prism kept in a set of two. Just their hypotenuse is connected together like this. Then there is the formation of plane polarized light. Plane polarized light. Plane polarized light. Here the photons or quanta, they vibrate in only one direction. There is only one direction. Now when we pass the plane polarized light through enantiomer, this is enantiomer. In this we have enantiomer. So in one case, this is on the angle of 180 just vertical rotation. This light or this vibration will be rotated to right hand rotation. Right hand rotation. So here enantiomer will be dextrorotatory. So dextrorotatory rotates the plane polari line toward the right side, and it is called as dextrorotation. It is called as dextrorotation. Dextrorotation. It is called as dextrorotation. We rotate the plane polari line. Now, in other case, here this is one condition. If we have other isomer, let it be first enantiomer. Here we have second enantiomer. Now, in this condition, when we pass this plane polari line, so here it will be able to rotate toward the left side, left hand rotation, and it is said to be levorotatory. Levorotatory means rotation toward the left hand side. So the point is that the enantiomers are D and L, or D and L. This is one part. Now, the enantiomers are able to rotate the plane of polari light when they are in pure form. If we write like this, dl or plus minus or dl. So here by mean we say same type of enantiomers are present together, and here there will be no optical activity. There is no optical rotation. We say that this will be optically inactive. Optical rotation or optically inactive. It will be optically inactive. In this condition, we assume that they are in the amount of 50% each. It means if one isomer rotates toward the right side, other will rotate toward the left side in same quantity. So overall result will be 0. And if the percentage is slightly different, if one is 60%, other is 40%. So let 60% is the 60% D and 40% L. So it will dominate. Slightly it will be more toward the right side. It will not be there. It will dominate it. It will be unable to express the rotation. And this is called as mutarotation. So mutarotation is the angle to which the plane polari light is rotated. The angle to which plane polari light is rotated is called as mutarotation. Now, there is other point, racemic mixture. Racemic mixture means when the two isomers are present in same quantity. When two enantiomers are in equal amount, it is called as racemic mixture. So there will be no optical rotation. So no optical activity. Now, other point is racemic modification. Racemic modification is the process to separate the two enantiomers. Separation of racemic mixture into enantiomers. Into enantiomers, it is called as racemic mixture, it is called as racemic modification. So this is very important part about this. Now other point is, just I am coming to the main point, why enantiomers are able to rotate the plane of polarized light. It is due to the presence of chiral carbon. So chiral carbon is a carbon in which all the groups or atoms present, they are different. For example, here just all the four groups are different. And as a result, it is the condition of the chirality. We say this chirality. How we can identify? If we take like this is the mirror. Let it be object. So here there is formation of image. Now the object and image, they cannot be superimposed on each other. Here no superimposition is possible. No superimposition possible, and this is the condition for it is only one condition. It is the condition for chirality. So this is the basic point about the stereochemistry, stereoisomers, enantiomers, racemization, etc. Now this is a very important part, isocyanide test. So isocyanide test is very simple, that any primary amine, it is either aliphatic or it is aromatic. It is applicable only for the primary amines. And when primary amines are warmed, then the warming influence of ethanoic average, there is formation of corresponding isocyanide. There is formation of corresponding isocyanide. And this test is responded only by the primary amines. So this is very important to know that we can identify the primary and secondary amines. This test is used as a tool to identify. If we take the secondary amine, if we take the secondary amine, and if we take and we warm, so here there will be no smell. So this is very important reaction to distinguish primary and secondary. So this is methyl isocyanide. So for aliphatic as well as for aromatic. So isocyanides are highly unpleasant substances, and isocyanides are used as a base to prepare all the insecticides and pesticides. You all must knowing about the Bhopal tragedy. In Bhopal tragedy, this was the gas. Methyl isocyanide was released in the Indian carbide factory by due to accident. So this is isocyanide test.